A student skates up a ramp that makes an angle 30 degree with the horizontal. He or she starts as shown in the figure at the bottom of the ramp with a speed v0. यहाँ से v0 speed से start किया and wants to turn around over semicircular path xyz of radius r, during which he or she reaches a maximum height h at the point y. ठीक है, तो यहाँ पे height जो है वो h है. Okay. From the ground as shown in the figure. Assume that the energy loss is negligible and the force required for this turn at the highest point is provided by his or her weight only. Then G is the acceleration. Then we have to find out these all things. Okay. तो अब देखिए ध्यान से यहाँ पे, क्योंकि ये h ऊपर है, तो यहाँ पे इसका वेलोसिटी अगर हम लोग v माने तो क्या हो जाएगा, हाफ m v0 स्क्वायर इज इक्वल टू mgh प्लस हाफ m v square. ठीक है, m is gone, so v square becomes v0 square minus 2gh. So therefore v becomes root over v0 square minus 2gh. ठीक है, यहाँ पे ये हो गया वेलोसिटी इसका. ओके, नाउ इफ यू सी, है ना, अगर हम लोग यहाँ पे इसका FBD बनाएं, सो फ्री बॉडी डायग्राम अगर बनाते हैं, सो दिस इज mg एंड देन दिस इज तो ये है थीटा, सो दिस बिकम्स 90 माइनस थीटा, सो दिस इज 60 डिग्री, ये हो गया 30 डिग्री. सो दिस इज mg cos 60 डिग्री विच इज mg बाय 2. ठीक है, now ये mg by 2 is going to give us the centripetal force. So mg by 2 is equal to mv square by r. It's gone. So v square by r, that is v0 square minus 2gh by r is equal to g by 2. So therefore v0 square minus 2gh is equal to rg by half into gr. So therefore A option is correct, B option is false. Okay, now the centripetal force required at points x and z is equal to 0. See, it's very clear that at the highest point the v velocity is going to be minimum, and at these points the velocity is going to be like more, because it is, it's down, the potential energy loss is less. So the velocity at z is equal to velocity at x is greater than velocity of y. So therefore v square by r is going to be greater than at z than y. Okay, so therefore 0, that is wrong. It is maximum. The centripetal force is going to be maximum at x and z. Thank you.